Hey, this is Derek, and this section is about linear inequalities and interval notation. And, I just tried to shoot this, and it turned into this giant monologue of me talking through this box, and I don't think it made very good sense. And so I think what I want to do is talk through a couple of really easy examples that aren't even in the notes. And I think by doing it as an example, I can make much better sense of all this information than just kind of like mindlessly trying to explain this box. So let me just make up something really simple over here. So let's say we had something like x is less than 3. And I'm assuming that at some point in your mathematical life, you've seen these less thans, and then if it was going the other way, it's a greater than. So this is indicating all the numbers that are less than 3. And we're not including 3 because there's no equal sign on there. So that would be what is called inequality notation. That's the stuff up here. If I was going to graph this on a number line, so if I have a number line, and I'll just go 0, 1, 2, 3. Where are the x's less than 3? Going that way, right? Because this would be all the values that are less than 3. I don't have an equal, so I don't want to include the 3, but I want to include everything after it. So there's everything after 3, and then what I do for this endpoint is I'm going to use an open dot because there's no equals. And so the open dot says I'm not including the endpoint. And the last thing we're going to see with this is interval notation. So that was our inequality notation is right here, our graph is right there, and then have interval notation. So what interval notation is we're going to use the endpoints of the interval to describe the interval. So we're saying from left to right what interval this thing is representing. And so out this way is negative infinity. Out this way is positive infinity. So this interval right here goes from negative infinity, comes in, and goes up to the 3, but doesn't include the 3. So the way that we write that is a parenthesis, and then negative infinity, comma, 3, and then another parenthesis. So the parentheses mean that the endpoints are not included. You'll see on this next example I'm going to do, there we'll use a bracket to say when it is included with the equals. So this is all the stuff that would go with a less than, or for that matter, a greater than. But the important part is how these endpoints are working. There's no equals, so we get an open dot on our graph, and we get a parenthesis on our endpoint. And then because we can never get to infinity, negative infinity, infinity, always going to be a parenthesis. So now let's say I have x is, I did less than, so let's do x greater than or equal to 1. So that on a graph, there's 0, we'll call that one 1. Now I have an equals, and so I want a solid dot there to say that that endpoint is included, and my arrow is going that way. Okay, all the other math teachers will make fun of me, but an easy way to remember which way this is going is the inequality points the same way as the arrow, right? So if you have this going one way and this going the other, take a look at your graph, right? Because something's going wrong. For the interval notation on this, now we're going to start at 1 and we're going to go to positive infinity, but this time I want to include that 1. And so now we're going from 1, so I'm going to use a bracket, and that's how we say solid dot or equal sign in interval notation. And then on out to positive infinity, we still can't ever get there, so again, always a parenthesis. So that is the basics. That is what all of this stuff says, is what I just said there, and hopefully that was a bunch clearer than just me trying to read this box verbatim. The only other thing in here is when you multiply or divide an inequality by a negative number, you're going to need to reverse the direction of the inequality. Let me show you really quick why that is, and then I'll get into the actual examples. So if I have 2 is less than 3, well, 2 is less than 3, right? If I have a number line, and right here, 1, 2, 3, there's 2, 3. 2 is to the left of 3, so that is true. If I divide or multiply both sides by negative 1, and now I have negative 2, if I don't do anything, I'd write less than negative 3. But when we come over to the other side on the negatives, right, negative 1, negative 2, negative 3, negative 3 is to the left. It is the smaller number. So negative 2 is not less than negative 3. Negative 2 is greater than, it's more than negative 3. I would rather only owe someone $2 than $3, right? That amount is to the right. And so when we multiply or divide by a negative, that's where we have to reverse the direction of the inequality. So other than that, you actually pretty much know all the math in this section already, because the same exact stuff as what we did in 2-1. We just got now we're gonna have solution sets, and a little bit different ways of writing the answers. This is -20 is greater than -4x. I'm gonna write that a little bit bigger. And so to solve that, if I'm solving for x, I would divide both sides by 4. And I have -5 is greater than x. And so the x on that side feels really, really awkward to me. And so I can rewrite this. I bet someone out there is going, wait, did you just divide by a negative? And I didn't, right? So the number I divided by was actually a +4. So it's going into this negative. I'm getting a negative value, but notice I am dividing by a positive, but that's a spot, especially since it's written backwards, where it can be easy to mix that up. -5 is greater than x does not feel good to my brain. So what I'm going to do is I'm going to rewrite it. If -5 is bigger than x, then x is less than -5. And to me, that's the way I'm used to reading it. So I would rewrite it that way. That said, if I subtracted the -4x over and added the 20, I could divide the 4, it would flip, and I would be right there. So if I solve the x over, I would get the same exact answer. Anyhow, x is less than -5. And so graphically, there's our -5 right there. I'm using an open dot because there's no equals. Less than, so we're going this way. And that would be my graph. And then my interval notation would be from -infinity up to, and then not including a parenthesis there on the -5. This next one, again, let me write this a little bit larger. So now this time I need to multiply both sides by a -2 to get rid of the negative and then the 1/2. So I'm just basically multiplying by the reciprocal. You can think of it as -2/1 if you like. On this side, probably easier to think -2. Now here, if you look at what I'm actually multiplying by, what I did in red, I am multiplying by a negative number, and so that is going to flip the direction of that inequality. So we would have x, and now it is less than negative, and negative would make +6. So again, no equals, so open dot, and then we're going that way. So this would run from -infinity and then up through 6. Okay, for number 3, I just wrote a little bit bigger down here. So 2 things I could do. I could distribute. I think I will go ahead and do that since that's what I did in the notes, in case people are following along with those. So 2 times 3 for 6, 2 times 5 minus 10x less than or equal to -14. The alternative was, since that 2 goes into 14, I could have also just divided both sides by 2, and then that would have made this just the 3 minus 5x, and that side -7 gave me a little bit smaller numbers. So either way, good. Next, we're trying to get everything away from this x, so let's subtract the 6 over, because that is a +6. We'd be subtracting to undo it. And that leaves us a -10x is going to be less than or equal to -20. And then here, the -10 is multiplying that x, so we're going to divide to undo that. And I am dividing by a negative value, and it's almost always on this last step is when you do it. So that's the spot you got to pay attention. So subtracting the 6 was fine, but it's dividing, multiplying, dividing, that lead to having to reverse the inequality. So x is greater than or equal to 2. So graphically, we're going to use a solid dot to include the 2, and then we're going that way. And now this will be a bracket on the 2 and then out to infinity. Okay, so number 4, I will clear these parentheses first. So that's going to be a -6x right there, minus and minus, plus 18, less than -4x plus 12. And then let me get these two combined, because it's a good habit. And that's going to be 26 Okay, then I will add the 4x over. And then maybe we're getting good enough at this that I can subtract the 26 at the same time. I think I've been showing them kind of one step at a time, but we can also do both those steps at once, which is just kind of nice for saving a little space. So right here we'd have negative 2x, that would cancel. This is less than, those cancel. And then 12 minus 26 would be negative 14. And then we can just divide over. And then x, and that was a negative again, so that flips that, is going to be greater than 7. And so we'd be up there going that way. And then our interval notation from 0 to, from 7 to infinity. This one, before I worry about that fraction, it will be easier if I get that 2 out of the way first. So let me bring that over. And then we have negative 3 halves x. Those are gone, less than or equal to negative 3. And now that I have it back to just a fraction and number, I can just do the bit with the reciprocal. And that will clean that right up. So negative 2/3 on this side, negative 2/3 on this side. Those 3's drop out, and I'm left with x. I did do a negative, so greater than. And negative would make that positive on my 2. And so and that's an equals 2, so we have a solid dot going that way, and 2 to infinity. So I think towards the end of the homework, you stop having to graph, and then the answers maybe come out to not as nice numbers. So this is just a few examples from there. So here we'd have 7 less than 1. I'm going to go minus 4 times x. And then minus 4 times that 2 for minus 8. And then I'm going to put these together before I move stuff around. So 1 minus 8, that would leave me a minus 4x minus 7. And then careful not to cancel those, because this one's a plus 7, that one's a minus 7. So when I bring the 7 over, so we have 14 over here. And then I'm going to divide out the negative 4. And now I can reduce that fraction. So this is going to go, I can knock a 2 out of both of those. So it'd be negative 7 halves is less than x. Again, that feels awkward to me, so I would rewrite it. If you just think about, like, the inequality is still going to face the same way. The big part, if it was a shark or an alligator or whatever that wants to eat the x, it's still going to do that, right? So when we rewrite it, we just reverse that to maintain the same direction. So both are correct. Okay, so for this one, I will clean up those parentheses first. And copy this part down. And then again, we want to collect our like terms before we start moving stuff around. So this is going to go negative 2x, 12 minus 8, that's going to be plus 4. And then copy this down again. And then once we have that, let's add the 5x over this way. That'll be nice because the sign will come out positive. And then again, the same step, I'm just going to show this, that I'm going to subtract that 4 as well. So here we have 3x, those are gone, less than, those are gone. 2 minus 4 would be negative 2, and then divide over the 3. And then x is less than negative 2/3. And then for interval notation on that, that would be negative infinity, less than, so the graph would be going that way, to negative 2/3.